So I wanted to talk just briefly about some comparison operators. This word comparison, right, comes from the word compare. Comparison operators are things that let us compare, let us write down a comparison between two values. So for example, we might want to compare the value of 3 plus 2 to the value of 5. How do those two values compare? Well, obviously they're equal to each other. Now here's the way I want you to think about how to draw an equal symbol. Now I know you know how to draw an equal symbol, but I want you to tweak sort of what you're seeing when you draw that. I want you to see the equal symbol as two lines whose ends are the same distance apart. And what I mean by that is that the distance from here to here is the same as the distance from here to here, and it's that distance being the same that's sort of describing the fact that this value is the same as that value. So this obviously means that 3 plus 2 is equal to 5, and what that means that the two values have the same value. So we can say 3 plus 2 is the same value as 5. The reason why I want you to think about that equal symbol as being representing equality by saying that these two endpoints are the same distance apart on both ends of the equal symbol is so that we can talk about the less than symbol and the greater than symbol. I know that we usually write the less than symbol, for example, like this, but if you can kind of suspend the way you're used to thinking about that and see that as two lines and maybe put a little bit of distance between them. See, there's just a little bit of distance. If we zoom in close, they're not quite touching. And what I want us to understand about this is what this symbol is going to do for us is it's going to say that the value that's smaller should be on the side of the distance that's smaller between the endpoints. And the value that's greater should be on the side where the distance between the endpoints is greater. So if I were comparing things like 4 and 7, right, we obviously know that 4 is less than 7, so 4 should be on the side where the distance between the endpoints is less, and 7 should be on the side where the distance between the endpoints is greater. Now we obviously don't usually draw those with actual distance between one of those endpoints, so we'll go ahead and fill that out the rest of the way, right? And we can do the same thing the other way around, right? We can say that if we want to talk about 7 compared to 4, 4 should still be on the side where the distance between the endpoints is smaller. So to make this true, we have to go ahead and put the smaller distance on that side that has the 4 on it. All right. Let's go ahead and have you guys try one. Do me a favor. Actually, I'm going to have you try 2. I'd like you to fill in which inequality symbol you would use for comparing 3 and negative 8. And I'd like you to go ahead and fill in which inequality symbol you would use to compare 3 and the absolute value of negative 8. Go ahead and hit pause in your video. Think that through. Write an answer down. All right, welcome back from being paused. If you didn't pause it now. Write down an answer. Which of these things is greater? Is it 3 or is it negative 8? It turns out the way that we're going to define this idea of greater, that we're going to say that 3, because it's more positive than negative 8, we're going to say that 3 is greater than negative 8. All right. Now, something different is going to happen over here. Remember that the absolute value of negative 8 is the size of negative 8. What is the size or the distance from 0 for negative 8? Well, it's 8, right? So really what this is asking us to compare is 3 and 8. What's greater, 3 or 8? It turns out that 8 is greater than 3, which means 3 needs to be on the side where the ends are closer together. So since 3 is less than 8, 3 is less than negative 8.